Making predictions. The percentage of workers who telecommute at least once a week was 26% in 2000, an increase by about 3.6 percentage points per year. Let P be the percentage of workers who telecommute at least once a week at T years since 2000. Find the model of the situation. Predict what percentage of workers will telecommute at least once a week in 2011. Predict when half of all workers will telecommute at least once a week. I highly recommend you read word problems at least twice. So let's try it again. The percentage of workers who telecommute, aka work from home, also known as work from home, right? At least once a week was 26%, so 26% in 2000. And increases, what is it doing? It's increasing by about 3.6 percentage points per year. So 3.6 percentage points is the increase per year. Let P be the percentage of workers who telecommute at least once a week at T years since 2000. Notice the variables that they're wanting us to use, P and T. And when did this start? Since 2000. Therefore, this is going to be our year zero, right? Okay, find a model of the situation. Predict what percentage of workers will telecommute at least once a week in 2011. So let's see, 2011, since 2000, how many years have passed? Well, it's 11 years, agreed? And last but not least, predict when half of all workers will telecommute at least once a week. Half, what does half represent? 0.5, right? Or 1/2, 1 over 2. But we're talking about percent. So percent, that would remain as 50%, right? So 50%. Okay, so let's find an equation. That means in the form of y equals mx plus v. This is our basic linear equation, agreed? And that's what we're looking at for most of this particular section. Okay, so y equals mx plus v, we can define that the m is our slope or the change, right? That's the m value. We call it the slope or the change. Y-intercept or start value, 0, b, right? It's the y-intercept. And we can see the v value on our equation is the v value on y equals mx plus v, the last value on it, the one that has no variable. It's the same as that v value in our coordinate for the y-intercept. So let's notice that once again, this started in 2000, and in 2000 it was 26%. So since 2000 means that's the year zero, as previously stated, agreed? So we always want to convert to singular years to make it easier to plot if we have to plot in the later future, or near, depending on the case. Okay, and also let's notice that in 2000, which is year zero, there were 26%. So we actually know the coordinates of the y-intercept. The starting year is year zero, so therefore it's 0, and the amount at that year, 26%. Okay, let's note the 26 on there. It's the v value of our y equals mx plus v equation at the top. Okay, and let's also note that it says that it increases 3.6 percentage points per year. So notice that that would be defined as our slope or the change. So what is it doing? It's increasing, it's changing at 3.6 percentage points per year. Okay, so therefore let's start with our formula, basic formula format. Y equals something x plus something, mx plus v, right? But let's fill in the blanks. So in this case, we know that the x value, or the value next to the x, is the slope, the change. So it changes by 3.6% points per year, agreed? So we know that that's our slope. And we know that the y-intercept, or the v value, is 26. So there is our formula technically. Find a model of the equation. We found a model. Hey, but wait. This can't be right. It's y equals 3.6x plus 26. They asked us to use the variables p and t. Not a big deal. We can convert it, right? Y represents p and x represents t. So let's convert it into p and t variables. So p equals 3.6t plus 26. And there is the actual final equation that we want to give as our final answer, right? The previous one was an intermediate step. Okay, let's try the next part. Predict what percentage of workers will telecommute at least once a week in 2011. That means 11 years have passed, right? So in the previous formula we found P equals 3.6t plus 26. the t becomes 11. So we substituted with an 11 because it's being 11 years. Agreed? And now we're just simplifying. So 3.6 times 11, 39.6. You might want to try your calculator for this one. For the 3.6 times 11, it could help. And then 39.6 plus 26, that should give us 65.6% roughly. So therefore, in 2011, the percentage of people who telecommuted or worked from home was roughly 65.6%. There's our answer. Okay, let's move on to the next one then. Predict when half of our workers will telecommute at least once a week. Half once again means 50%. So in the previous formula, P equals 3.6T plus 26, right above. We're replacing the P-value in this case because it's 50%, it's a percentage. So 50 equals 3.6T plus 26. And let's solve for T. T is the only thing we don't know in this case. So solving for T, that means we gotta get rid of addition and subtraction first, the 26. So minus 26 from both sides of the equal sign. 26 minus 26 at the right side cancels out. 50 minus 26 gives us 24. So 24 equals 3.6T. Agreed? Try your calculator. Your calculator could be useful for this as well. Quick checks. Make sure I'm doing this correctly. Okay, so 24 equals 3.6T. How do I get rid of the 3.6? Well, keep in mind it's multiplying with the T. Opposite of multiplication is, you got it, let's divide it out. Divided by 3.6 on both sides. Remember, what you do to one side, you must do to the other. 3.6 divided by 3.6 cancels out. 24 divided by 3.6 therefore gives us 6.7. T represents years, right? So therefore we might want to round this to the nearest complete year. If it was 6.5 or above, it goes up a number, right? If it's 6.4 or below, or 6.4999, etc., it would go down into just a 6. So it's above or at 6.5, right? In this case, 6.7. So it goes up. So let's round it to 7 years, roughly. So that means that in the year or after 7 years, well, when does this start? 2011, right? So that entirely means that in 2007, because we go 2000 plus 7 gives us 2007. So in 2007, half of the workers telecommuted. And there is our answer for this particular case.